In 2014, the Western Maryland Scenic Railroad announced that it had acquired Chesapeake and Ohio number 1309 from the Baltimore and Ohio Railroad Museum. The announcement immediately drew attention within the railroad preservation community. Number 1309 was not just another preserved steam locomotive, it was the last steam locomotive constructed for a Class I railroad in the United States, built by the Baldwin Locomotive Works in 1949. The railroad's goal was ambitious: restore the massive 2662 Mallet locomotive to full operational condition and to use it as a flagship engine for heavy excursion service between Cumberland and Frostburg, Maryland. At over 600,000 pounds and featuring complex articulated machinery, 1309 represented one of the most challenging restoration candidates in North America. Many observers questioned whether such a large locomotive, one that had not operated since the 1950s, could realistically be returned to service. Despite skepticism, WMSR moved forward, citing the locomotive's historical importance and the railroad's need for a powerful engine capable of handling long grades and heavy tourist trains. Before restoration could begin, the locomotive had to be moved from the Baltimore and Ohio Railroad Museum to the WMSR maintenance facility in Cumberland. Transporting a locomotive of this size was a significant logistical challenge, to say the least. The engine was separated into major components, including the boiler and frame sections, and transported using specialized rail movements and heavy equipment. Years of static display meant that bearings, journals, and moving parts could not simply be rolled into position. Every step of the move required careful planning to avoid damage to already fragile components. Once the locomotive arrived in Cumberland, it was placed inside the WMSR shop complex, where the full scale of the restoration effort began to take shape. Restoration work began with the complete disassembly of number 1309. The locomotive was stripped down to its core components, including the boiler, running gear, articulated engine units, cylinders, valve gear, and tender. This phase was critical, as it allowed crews to properly assess the condition of parts that had not been inspected internally since the locomotive's retirement. While the exterior of the locomotive appeared relatively intact, internal inspections revealed extensive wear, corrosion, and metal fatigue. Modern, non-destructive testing methods, including ultrasonic thickness testing, were used to evaluate the boiler shell and firebox. These tests measured remaining metal thickness and identified areas that would require replacement or reinforcement. The findings confirmed that a cosmetic restoration would not be sufficient. The locomotive would require a near-total mechanical rebuild to meet modern safety standards. One of the most complex aspects of restoring C&O 1309 was its running gear. As a mallet-type articulated locomotive, 1309 features two sets of driving wheels, a rigid rear engine unit and a pivoting front engine unit designed to navigate curves while distributing weight efficiently. The driving wheels, axles, rods, and bearings were removed and carefully inspected. Decades of inactivity had allowed corrosion to develop on bearing surfaces, while old lubricants had hardened into abrasive residue. Several components were sent to specialized machine shops for resurfacing and machining. Side rods weighing several tons each were reconditioned and balanced to ensure smooth operation at speed. Bearings were remetaled or replaced, and clearances throughout the running gear were brought back within operational tolerances. This phase required repeated fitting, removal, and reinstallation of parts, a slow and precise process that consumed years of labor. The boiler restoration became the most time-consuming and technically demanding phase of the entire project. All boiler tubes and flues were removed, exposing the interior of the boiler and firebox for detailed inspection. Inspection revealed widespread thinning of steel in critical areas, the result of age, corrosion, and past operating stresses. Sections of the firebox and boiler shell required extensive repair or replacement to meet Federal Railroad Administration requirements. New boiler tubes, flues, and superheater elements were fabricated and installed. Welding work was performed under strict regulatory oversight, with repeated inspections required at each stage. In some cases, repairs had to be redone after additional flaws were discovered during testing. Unlike some modern restorations that convert locomotives to oil firing, 1309 retained its original coal-burning configuration. This decision required the reconstruction of grates, ash pan systems, and draft controls, all of which had to function reliably under excursion service conditions. As the restoration progressed, delays became increasingly common. Parts that initially appeared usable were later found to be beyond repair. Contractor schedules slipped, funding constraints slowed progress, and unexpected technical issues emerged. The project drew criticism from within the preservation community, with some questioning whether restoring such a large locomotive was practical or even financially sustainable. Others argued that resources would have been better spent restoring smaller, simpler engines. Yet, despite these challenges, work continued incrementally. The project became a test case for what modern steam preservation could realistically achieve in the 21st century. By the late 2010s and early 2020s, the restoration entered the reassembly phase. Rebuilt components were returned to the locomotive and installed in sequence. The boiler was mounted back onto the frame, and the running gear was reinstalled and aligned. Air brake systems, injectors, lubricators, and auxiliary equipment were rebuilt or replaced as needed. Modern safety systems and monitoring equipment were discreetly integrated into the locomotive to comply with the contemporary operating regulations, while still preserving the outward historical appearance. With reassembly nearing completion, the boiler underwent hydrostatic pressure testing. These tests verified that the boiler could safely contain operating pressure without leaks or structural failure. After passing inspection, the locomotive was slowly brought up to steam for the first time in more than 6 decades. Initial firings were conducted cautiously, with crews closely monitoring temperature, pressure, and mechanical behavior. Short test movements followed, marking the first time Chesapeake and Ohio number 1309 had moved under its own power since the 1950s. In the early 2020s, C&O 1309 officially entered excursion service on the Western Maryland Scenic Railroad. Its return to operation marked one of the most complex steam locomotive restorations ever completed in the United States. The locomotive's immense power made it well suited for the steep grades and heavy trains of the WMSR route. Its operation also validated the railroad's original decision to pursue an ambitious project, despite years of delays and criticism. Today, 1309 stands out not only as a working locomotive, but as a moving artifact, a reminder of the final chapter of American steam power and the determination required to bring it back to life.